After watching this video, you will be able to solve any problem in physics given to you from any exam, any book, or any difficulty level. So stay tuned till the end. Now, of course, every problem in physics is unique. There is no one magical technique, magical spell that you can use and solve it for every single problem given to you. No, every problem is different. Every problem is unique. It is no guarantee that if you know how to solve one kind of problems, you can apply the same technique for similar problems in the future. No, there are infinite scopes for variations to create complicated and intricate systems, and hence, if you are thinking that this video will give you a magic spell, then it will not. It will just clear some confusions that you have and will enable you to get over this fear or a block that students usually associate with solving physics problems. And that is true. Because once you've been studying for 2 years, 3 years, and you have a large amount of information stored in your head, you have so many concepts, so much intuition, so many equations, so many expressions, that once you have been given a difficult problem, many students complain that they just sit over there staring at the problem, not knowing what to do. Their mind goes completely blank because you get overwhelmed with so many different approaches that you can take. You can't seem to apply that one particular thing that the question wants you to apply. So how to get over that block? All you need to do is streamline your thinking process, and an easy way to do it will be discussed in this video. Here I have prepared a simple 5-step plan that you can use to streamline your thought process, and you can apply this to any problem given to you, and you will notice that once you just follow along these 5 steps one by one, without knowing, you will reach the answer in less time than you would have ever thought that you would take for that particular question. Let's go through these steps one by one. The first step says that you have to read the problem carefully, look at any diagram given to you, and just understand the topics that it is trying to cover. Many problems in physics are not isolated to one particular topic. You will need concepts from 2 to 3 chapters. Sometimes you will need advanced concepts from maths or chemistry also to solve that problem. All of this you should identify as the first step, so that you have so much memory stored, you have so many concepts all over the place. You need to know what actually will apply to the problem at hand. Identifying the topics in the question will help you narrow down the search. So you know, I need to look in this area of my mind, so you can just go there and search what will be useful. I have marked this with a red star because the topics that you identify might change over the duration of the problem. It's not necessary that if you think that a particular problem is from thermodynamics, it can be a problem of simple kinetic theory of gases or simple properties of matter. You never know. So don't do the first step and let go of it. No, know that because physics problems are very mixed, you can change the topics once you figure something else about the problem given to you. Now that you have identified the topics, you know where to look for information. Start looking for information. But how do you apply that information to the system? First of all, you need to know what exactly the question is asking you to imagine. Construct the system. If you have been given a diagram, then a lot of the process has been already done for you. But if you have not been given the diagram of the system, you should either imagine the diagram in your head, or simple case, draw the diagram in any rough workspace given to you. Visualizing the diagram, visualizing the system helps tremendously in applying the concepts or intuition that you have learned over the years. Now in this step, you will also apply some techniques that you have learned to solve specific types of problems. For example, in problems related to mechanics like laws of motion, you will draw the free body diagram of the objects, you will draw the torque diagrams, or you might draw the coordinate systems. All of that sort all comes under construction of the system. Constructing system doesn't just mean drawing diagram and letting go of it. No, constructing the system means everything about the problem should be in front of your eyes. Over here in this step also, you will identify all the information given in the problem and what is not given in the problem specifically, because whatever is not given in the problem will be more often than not what you are asked to calculate. So in the second step, you not only have to draw the diagram, not only have to quantify the diagram, that is, write all the information given to you, but also make a note of what all is not given in the question, or what other variable quantities you have introduced in the question while constructing the system. For example, in pulley problems, we often draw tensions in the string and label them T without actually knowing what the value of T is. All of these things come under unknowns, variables, and you have to make a note of them so that you don't forget that, okay, these quantities I might have to calculate. Once you have constructed the systems and you know what are the known quantities, what are the unknown quantities, your aim is now to bridge the gap between the knowns and the unknowns. Over here, the concepts that you had identified in the first step will come into play. Start by writing down whatever equations you know about the topics. If you identified the topic as center of mass, write down the expression for center of mass. If you identify the topic as collision, write down the equation for momentum conservation, energy conservation, and see that, okay, I can plug in these known quantities over here and these quantities in the equation are unknown. If whatever you have been written down, most of the variables, most of the parts of the expression directly relate to the question, then you know that you are thinking in the right direction. Once you know how to bridge the knowns and the unknowns, once you have all the equations figured out, now comes the time to actually solve them. But first, there might be some hidden techniques or shortcuts that you can apply to make your work much easier. Of course, if you can't find any, it is always a good move to just shut up and calculate. Brute force the equation, brute force whatever calculations you've been given, you will reach the answer, no doubt. But if you have practiced enough, if you know the concepts well enough, then you might be able to identify some shortcuts that you can apply to make your calculation process easier. Now, of course, mastering the fourth step comes with only experience. So there is no such thing as too much practice in physics. You should always keep practicing day in and day out to improve your problem solving skills, to improve your intuition, and all of that you will realize that step 4 becomes easier and easier the more you practice. And of course, no one is perfect. Everyone makes mistakes. You need to identify your mistakes before moving on to the next question. This is very, very important. If you have been writing down your solution carefully, if you have not been skipping any steps in the middle, if you have drawn the diagram neatly, labeled everything properly, then it should be easier to identify your mistakes and verify whatever your results you've been given with the question at hand. For example, if in the question it says that you have been given a uniform electric field, and after so much calculation, you come to know that electric field has some time dependence, then that is a contradiction and you need to figure out where exactly you made the mistake so you can start over from there. Of course, you'll notice that this is a very, very generic 5-step plan. It talks nothing about the kind of systems that you will encounter. It talks nothing about the kind of techniques that you'll apply, the kind of equations that you might have to solve, because again, there is no one such formula. You can only streamline your thought process. You can only take a systematic approach to solving the questions. If you want to note down the 5-step formula, this will help you tremendously in solving problems. Now, let us take a look at how we can use this to solve very, very advanced level problems. This is one problem that appeared in the NEST exam. It talks about 2 semi-infinite wires which are placed along the x-axis and the z-axis respectively, and a square loop along the y-axis kept in such a way. Now, the first step was to identify the topics. Reading the question carefully, the question ends with finding the induced EMF of the loop. So obviously, we need to use concepts from electromagnetic induction. Right? This, make a mental note of the topic electromagnetic induction. Now we have to construct the system. The diagram has already been given to you, but of course, this is not the end of construction. You need to draw out the plans you need to draw out the architecture of this system itself. The inner workings of the system should be laid out in front of your eyes. How is that possible? You know that an infinite straight wire applies magnetic field to its surroundings according to the right hand thumb rule. For example, this wire will apply magnetic field in this way, and this wire will apply a magnetic field in this way, right? So in any point inside this loop, let's draw the point like this. From the wire along the z-axis, you will get a magnetic field going into the plane, and from this wire along the x-axis, you will get a magnetic field going downwards along the z-axis. So these are the two magnetic fields that the wires will exert around them. Now you need to calculate the induced EMF. For that, you need the flux through the loop. The flux through the loop has not been given. So make a mental note that the flux is also an unknown quantity. And what are the known quantities? The currents are the known quantities, and the distances from the loop are the known quantities. But this known quantity has been given ambiguously to you. If you have been solving enough problems from electromagnetic induction, you know that the distance of the arms of the loop from the wires is also important. So if you calculate the distance of the wires from this end, then you get it as 2a minus half of a. 2a minus half of a, that is equal to 3a by 2, becomes the distance of the first arm of the coil from the wire. And similarly, the distance to the second arm of the wire comes as 2a plus a by 2, that is 5a by 2. These are the distances from the wire. All of these things you need to label carefully while the construction of the system. You need to know where the magnetic fields from these two wires will be, how it will be, and you need to know the exact distances of the loop arms from the wires also. And now you know that the unknown quantity is the magnetic flux. And you need to calculate this quantity also if you want to proceed with the calculation of induced EMF. Construction of the system is over. Now we need to bridge the gap between knowns and the unknowns. How would we bridge the gap? We know that magnetic flux is the number of magnetic field lines or amount of magnetic field passing normally through an area. For that, we need to calculate what the magnetic field exerted by these wires will be through the loop. So actually, magnetic field was also an unknown quantity in this question. So we should label magnetic field also as unknown. Can we calculate magnetic field for this type of setup? We know a semi-infinite wire has current kT along both the axes. So if we apply Biot-Savart's law for a semi-infinite wire at a distance of, let's say, x, then the magnetic field at this distance comes out to be mu naught I upon 4 pi into x sine theta 1, that is the angle that it makes with the other end, which is at infinity, plus sine theta 2. If the wire was like this, then this will be theta 2 and this will be theta 1. Sine theta 1 plus sine theta 2 is how we write Biot-Savart's law for a straight wire. Now, because there is a semi-infinite wire and we need to find its magnetic field along its end point, the angle theta 2 becomes 0. So instead of sine theta 2, we would substitute sine of 0. That would just make it sine of theta 1. And since it is a semi-infinite wire, the angle theta 1 becomes 90 degrees. And we know sine 90 degrees is 1. So the magnetic field at point P comes out to be nothing but mu naught I upon 4 pi x. Now this magnetic field decreases with the distance away from the wire. So for both of these wires, the value of magnetic field over this region will continuously decrease as 1 upon x, right? One more thing you should note over here is that only the magnetic field normal to the loop will give some electric flux through it. The magnetic field which is into the plane of the loop, along the plane of the loop, will not give any magnetic flux. So you need not even consider the wire along the x-axis. This question then reduces to just simply finding the magnetic flux due to one semi-infinite wire. This counts as the shortcut that we need to use, because there is no magnetic flux due to the wire along the x-axis, so we need not calculate the magnetic flux due to that at all. Now, since a magnetic field is continuously changing, we know that for any continuously changing quantity, we need to use calculus. So let us consider an element at a distance of x from the wire and having thickness dx, and we can find the flux along this element and call it d phi. Of course, the total flux through the loop will be the integral of d phi. Now, if we calculate the magnetic flux through this element, what do we get? We get first of all the magnetic field through the element, which will be constant as mu naught I upon 4 pi x, and then we need the area of this element. The area of this element will be simply the side length into the thickness. Side length is a and thickness is dx. Mu naught I and a are constants and 4 pi is also constant. So the total magnetic flux becomes mu naught into I, which is of course a variable, upon 4 pi into integral dx over x. And we need the limits as distance from one end and distance from the other end. Over here, our construction of the system will come into play. Distance from one end is 3a by 2 and distance from other end is 5a by 2. So we apply the limits over here, 3a by 2 and 5a by 2. And all that is left is now to integrate. Dx over x is a very simple integral, which comes out to be mu naught I upon 4 pi. Of course, there is a over here into log of 5a by 2 upon 3a by 2 becomes 5 upon 3. So this is the magnetic flux through this loop. Now we need the EMF, so we can apply Faraday's law, that is EMF equal to minus d phi by dt. Since we only want the value of magnetic flux, we can ignore the negative sign. And in the magnetic flux, all of these quantities are constant. Only the quantity current is variable, and we know current is increasing linearly with time. So instead of differentiating the entire flux, we can just substitute the rate of change of this current, which is constant. Hence the total induced EMF becomes mu naught into k into a over 4 pi into log of 5 over 3. Of course, this is a high level problem, and you can see it took us so much calculation to get the answer. But since we had a general approach in mind, we knew step by step what exactly we need to do, right from reading the problem for the first time till getting the final answer. We knew exactly what we are supposed to do. This is what I meant by streamlining your thought process. Even if you feel that, okay, this problem is very complicated, I can't think forward, I can't determine how exactly I can go to the answer, you do not have to get to the answer. All you need to do is get to the next step in the plan. Once you have identified the topic, all you need to do is construct the system. After that, all you need to do is write down the knowns and unknowns, bridge the gap. This is why a step-by-step approach is very useful, because understand that solving a problem is not a one-trick task that you are over here, the answer is over here, you can take one big jump to the answer. No. If you follow a step-by-step approach, streamline your thought process, it is possible to solve any problem given to you. Of course, as an ancient human proverb says, what one fool can do, another can. So don't think that a very difficult problem given to you is not solvable by you. No, it is most definitely solvable for you. There are people in the world who solve these problems. There are people of your age who do these problems, who do many of these problems and get into the institutes that you want to get into. If they can do it, so can you. They are not some aliens from another world that have come to dominate your exams. No, they are humans, they are fools just like you. Whatever they can do, whatever problem they can solve, whatever exam they can clear, you can also clear that exam. You can also solve those problems. You can do whatever anyone else can. I hope this video was useful to you. I hope you will apply this 5-step plan you learned, and I hope that you will solve many problems in physics. I hope you practice well, and also all the best to get into your dream institute. Thank you.